Ladies and gentlemen, first of all, I would like to apologize to you for doing this presentation in English because of my maybe lack of technical words in Turkish. I prefer to do this presentation in English. My name is Mehdi DEHSHAT, and as the R&D manager of the EUROPOWER company, it would be my pleasure to be here and share with you guys some of our achievement in ESS and also microgrid integration systems. Before everything, everybody knows that this event was postponed because of the earthquake happened on February 6th. And unfortunately, it was a very, very bad disaster for all of us. We lost many people in that earthquake. And I would like to start my words with a poem from one of the greatest poets from Iran, Sadi Shirazi, in memory of the victim of this earthquake. Human beings are a member of a whole in creation of one's essence and soul. If one member is afflicted with pain, other members uneasy will remain. If you have no sympathy for human pain, the name of human you cannot retain. I hope my Lord has mercy on the soul of those who passed away in this incident. Amen. My presentation will be about the microgrid and energy storage system. I have a very short time, and during this short time, it's a little bit difficult to deeply describe the microgrid and also ESS. But I will do my best to describe everything very well. So this is the content outline of my presentation: introduction, need of microgrids. I will pass it. What is microgrid? What is microgrid? Microgrid is a group of loads, interconnected loads that are connected together. Not only the loads, some source of energies, some generators, let's say, and that are connected together, but they could be controlled separately, let's say. This could be a network. This could be a network in a building. This could be a network in a building, consists of, for example, in some residence you are living, there is some generator. You will have some solar cell power panels in your building, and also you are connected to the public grid for supplying your building. This is somehow a microgrid. This is a very small sample, but it could be a larger one, like a city, small smart parts. This microgrid is a very, very hot topic of electrical engineering at the moment. Many of the top universities in the world are doing PhD courses for this topic. And it's a very, very attractive and hot topic in the electrical engineering and also power distribution issues. As you see in this picture, a load could be supplied from different source. In a microgrid, it could be some local generator, some gas turbine, some solar cell, some wind turbine, and connecting together, and even this could be a little bit deeper and much more complicated that I want to show it to you in next slides. So, why do we need microgrids? Why do we need microgrids? Microgrid could be an answer to energy crisis. How? How it could be an answer to energy crisis? Imagine you are living in a large city like Ankara here, and because of the fault in some street, let's say, all the neighbor will be in blackdown. By actually using and configuring microgrid in the city, the smallest possible part of the network and grid will be disconnected from the network. And it will help you to stabilize as much more trustable network. So actually my topic is not only talking about the microgrids. I will, this is actually actually a pass, because I'm not saying, because I'm using some computer here and these 2 pages are not saying, sorry. Here, let's say the next slide, here. Component of the microgrid. What would be the microgrid components? Everything. Any consumer and any power generator in the network could be a microgrid components. EC or DC, doesn't matter. It doesn't matter. There are a lot of energy resources and energy storage technologies and systems that would be supply energy. For example, compressed air, that I will describe this technology in next slides. Compressed air could be another source for energy. PV, wind turbines could be another, and even electrical vehicles. You see, this is a hybrid AC-DC microgrids, because we have a lot of DC consumers. This DC, for example, consumer. You know, in this exhibition, you can see a lot of DC chargers, EV chargers that are able to charge e-cars. So, imagine you arrive after 8 hours of working to home and connecting your car to grid and want to charge your car. Okay, this is consumer. But this car could be a power source. This is technology that we say it, EV to grid, electrical vehicle to grid, EV to grid technology that says every car in every place could be energy storage, potentially could be energy storage system in any network and any grids. This is a very different topic. Actually, I don't want to go deep down to this topic. Microgrids actually have generally two types of mode of operation. One is grid connection mode. It means you are connecting to a grid. Some part of your grids are supplying, from the public grid, and you also, because it's a microgrid, there is also some power generator and power sources. So this is a grid connected mode. This is that we are generally all of us thinking about such a grid. But there is another mode, which is island mode. In this island mode, which is actually the microgrid, very, very specific attribute, let's say, is it could be working completely isolated from the grid, but supplying from some source in the grid internally, and disconnecting, or let's say shedding, the unnecessary loads. This is the island mode of microgrids. You don't have any loss. You only just disconnecting your microgrid from the public grid, supplying from some local generator, and just shed the unnecessary loads. Okay. Need for ESS in microgrids. Need for ESS in microgrids. Just a moment, because there is some mismatch here. Okay. From a network, from generator, from A part to Z part of any network, transmission or distribution, energy storage could be an answer to many problems and crises. How? In switchings, in distribution networks, in some local facilities, even in your home or any factory, it could be. How? I will describe you. Here, actually, this slide is somehow conclusion of integration of ESS and microgrid, let's say. Expected benefit of ESS in microgrid application. In renewable energies, for frequency regulations, for distributions, for commercials, for industrial, and so generally for microgrids. How? For smoothing, imagine, renewable energies are not stable, are not predictable. Energy storage are not predictable. You cannot predict how many days you will have sunny in the world in a year, or is it windy today or not? So your generation is ramping, different. Okay, this smoothing application that I'm talking about is a feature of ESS application in a grid. How? You will charge your energy storage system, and on a stability of the generation could be compensated by the ESS. Okay. Another one is the frequency regulation. This part, let's say, maybe is a little bit. May I have some microphone and going there? Okay. Actually, I prefer to. Okay, frequency regulation. A gap between power generation and demand on the grid causes grid frequency to move away from a nominal value, and this can be regulated using ESS to improve quality of electricity. What does it mean? If your generation, if your demand is much more or higher than your generation, your frequency and your voltage will be unstable. Okay, this lack of, let's say, demand and generation capacity could be compensated by ESS and energy storage system. Okay, power quality control for distribution network. For power quality, is a very critical issue for any electrical network. By let's say correct and right using of ESS and establishing right ESS system, it is possible to instead of using and establishing new power plants, it's possible to control the power quality in a network. And also for load leveling. What is load leveling? You know, all of us in our house, we have energy meter, and all of them have 3 tariffs: high demand, off peak, low peak, or let's say middle peak. Okay. During the low peak, your off peak, let's say, your ESS system could be charged and could be injected during the on peak. It will definitely affect your bill at the end of month. It is very, very important issue. And also for peak shaving. Peak shaving also is a very, very important application that could be executed in industrial or even some buildings. Means, for example, you have a demand contract with the electricity distribution company for 10 kilowatt, and you have to, for a short while, you have to supply, let's say, 50 kilowatt. What should you do? If you supply and get this 15 kilowatt, you will pay punishment to the distribution company. By this, I mean, by using ESS for peak shaving, for a short while that you will need to supply a higher power than your demand, it will actually prevent to don't pay more to the distribution company, to energy cell, let's say. Okay. And as conclusion of microgrid, ESS helps to stabilize the grid system through power smoothing control, as well as voltage and frequency regulation. All of them, I mean, all of these applications, at the end, integrated together in a microgrid system, have a lot of uncountable benefits. Okay, need for ESS in microgrids. Why do we need ESS in microgrids? High performance, safe, sustainable, and excellent economies. Actually, I don't want to go deep down to all of these topics. It takes a lot of time, and we cannot talk about it in just few minutes. Next slide, I want to show you the technologies of the energy storage systems. We all electrical engineers always thinking energy storage means only the batteries. No. Battery is not the only energy storage technology. A lot of mechanical storage system is available. Ultracapacitors is electrical, let's say, or electrochemical. Superconducting magnetic, compressed air, pumped hydro, fuel cells, flywheels, and batteries. I want to tell you some, let's say, the thing actually I've seen when I was a child, maybe 6 or 7 years. I've seen a truck, a very, very old truck, that the cranking system of this truck was by compressed air. It means the engine connected to some compressor, and the compressor compressing air in some tank, and stored the tank, compressed air in the truck, and just if it needs any cranking, starting the engine, it's used the compressed air energy. It's a very, very low, very, very old truck, maybe more than 100 years ago. The trucks belong. I'm not belongs to 100 years ago, but the trucks actually was very old. This is a table for conversion table of the capacity and the time of different technology of the energy storage systems. The batteries, let's say the batteries, electrical here, the green one, nowadays is the most accessible and achievable one, and much more cost-effective than others. Type of batteries that generally is very popular in the market from the past to now. Lead acid somehow is still available in the cars, some cars, old cars, let's say. Nickel cadmium, nickel metal hydride, lithium ion, and lithium metal. Lithium metal is not only one type. So a lot of type of lithium metals. It means one part of battery is lithium definitely as anode, and as cathode, a lot of combination of metals are acting as cathode. It's a totally different issue. And one thing, actually, the big question for me personally during the past years is why we electrical engineers didn't pass any topic or course in the university for batteries. None of us, I believe, none of us pass any, for example, let's say we have electrical machines, 1, 2, 3, electrical circuit 1, 2, 3 in these schools and universities. Why we didn't pass any topic for batteries? Very, very critical issue, very, very important issue. I can say maybe most of electrical engineers all around the world have a lot of lack of knowledge of batteries, include me. Okay, nowadays because of the e-cars, because of the ESS and different large usage of batteries in the world nowadays, educating the electrical engineers for battery topics and issues is very, very important. Advantages and disadvantages of microgrids. The major advantage of a microgrid is its ability during utility grid disturbance and separate and isolate it from the utility seamlessly. That I talked about it during my talking. Yeah. Okay. Actually, I described this topic. I mean, using microgrid helps us to have a much more stable network. How? By isolating the, let's say, fault or failed part of the network. In peak load periods, it prevents utility grid failure by reducing the load on the grid. How? By supplying and injecting much more power by the local generators, local suppliers and sources, let's say. The use of electricity and heat is very, very important, is permitted by the close proximity of generator to the user, thereby increasing the overall energy efficiency. Let's imagine you have a very small power source. Power generating definitely generate heat. It's normal. if you are using and configuring microgrid in your system, you can use this heat as a source of power, for example, let's say, to heating some water of your building or your facility. And it's already increased the efficiency. Microgrid can act to mitigate the electricity cost to their user by generating some of all of their electricity nets. And now, disadvantages. Voltage, frequency, and power quality are three main parameters must be considered by and controlled by any network. Because of the different and several type of sources, it's a little bit difficult to control the voltage and frequency and power quality of a microgrid. But it needs a lot, it takes a lot of, let's say, work and analysis, but it's possible. Electrical energy needs to be stored in battery banks that requires more space, maintenance, and even cost. Another problem, let's say, or disadvantage that I personally face with is resynchronization with the utility grid could be difficult. Imagine you have several microgrids with a different sources. Oh, pardon. No, it's okay. And they have a little bit difference in frequency and voltage level and power factors. It could be very, very difficult to synchronize all of them together. And if you want to sync all of them with the public grid at the moment, this is another disadvantage of microgrid. And also, implementing a new standard IEC 62786 of IEC standard distributed energy resources connection with the grid must be implemented with precision and perfection. If you take a look at this standard, you will understand my word very well. Very difficult standard for implementation and also in execution. Okay. So this is actually we, as EUROPOWER company, had several activities and also references in energy storage systems. A project that we did is a 1 megawatt energy storage for Ukraine before war, definitely. For DTEC company, this is a drawing, design drawing. You can see here the inverter, battery banks, and also distribution. The next slide is the arrangement. The arrangement of the kiosk, let's say. Also, very, very simple single line diagram. And this is the real photos of the Dawn project. I mean, panels, let's say. We as EUROPOWER have some actually very, very great, let's say, plan for this developing the energy storage systems in future. And in this regard, we did a lot of activities, and it's going on, and currently we are involving with them, and hopefully, let's say maybe next year, you will see some new products for energy storage system, which is actually the inverter, energy storage inverter is already, the design already done, the prototype manufacturing almost done, and we will test it very soon. The BMS, at the right side, the battery management system. The battery management system, which is my very favorite topic, very favorite topic, and also the battery pack, the battery packing solution. This is my actually presentation. It would be my pleasure to answer your question, if any. Thank you. Any question? One, two, three. I want to count. Okay. Thank you.